Okay, let's get started. So, so any questions before we start? Or can you all hear me? Yes, no.
I can hear you.
Okay. So let's just recall that given f of x, I'm just gonna go over a bigger than 0. This shifts a to the right. I'm just gonna skip the unit. Yeah, just when I say shift a, it means a units. Yeah. So if it's a is 4, it's 4 units. So shifts a to the left. And f of x plus a units up, and f of x minus a is a units down. So the thing is, I didn't go over, this is a bit harder to graph. I guess since everything's online, you probably don't need to graph this. So that makes, things easy. Even I can't graph it sometimes. So like, so the way, let me just say c f of x is stretch f of x, let me see, is everyone in? Yeah, stretch. So this is for c, with the make a convention, so c is bigger than 1. Stretch f of x vertically by factor. By c, I mean factor of c. And then 1 over c f of x is shrink. And obviously, you could do it on the domain. So f of cx is shrink c, let me just put this, horizontally by c. And f of 1 over cx, or some people write x over c, is stretch horizontally. So I think this is kind of hard to draw, right? So I think for computer people, the best thing you should think of is if you download a Google image, and you know how, like, if you have a picture, you have, like, and you go to, like, the corners, like you have that the thing where you could, like, stretch and, like, shrink. Just think of it like that. Like you download the graph, and then shrink horizontally means, like that. you're shrinking like the photo. And then f of negative f of x is reflect about x-axis, and f of negative x is reflect about y-axis. Yes, so I mean, for shrink and stretch, like, it shouldn't change, like, how your graph should still look the same, right? Except maybe fatter or skinnier, but the shape should look the same. So if they give you a graph with, like, shrink or stretch, I just check certain points and see they match. I think that's honestly the best way. So before I conclude transformations, I think it's an important thing to say, like, how I told you, if I gave you a function that's transformed, you start with, like, the original, and then you do each transformation one by one, right? So note that order sometimes matters, right? So if I do, I don't know, negative e to the x plus 4 minus 7, right? So there's, if you're really careful, you're going to see there's 3 different transformations, right? There's shift left by 4, moving down 7, and you're negating. So if I go back, how do I go back? Let me see. No, that's how do I go back to the previous? That's how. Okay, so if you notice, it's negative f of x, right? So I'm reflecting about x-axis. So you see that there's 3 transformations, but the order matters, right? So let me just say, if you decide to do it like this, shift 4 left, then 7 down, and then reflect, this is the wrong thing. Yeah. Why is that? Because let's see, what happens after you shift 4 left? You go from, so this is, e to the x plus 4. So after shifting, e to the x, sorry. After shifting 4 to the left, it becomes e to the x plus 4. And then when you shift 7 down, you're subtracting 7 to this equation. Right? And then if you reflect, you're negating the whole equation, right? So, so what you graphed, if you do it in this order, is actually negative e to the x plus 4 plus 7. Yeah? So you see the order matters, right? So what you should have done, I guess, if you like, I mean, sometimes order doesn't matter, sometimes it matters. Like you just have to check what equation you get at the end, right? So in this case, this will work, right? Shift 4 left, reflect. So by reflect, I mean x-axis. And then 7 down, that will work because you start off with e to the x. You go to e to the x plus 4. Then you negate it. Then you go 7 down, so you so if you want to go this route, you see you would have to have moved 7 up, right? Instead of 7 down. Because if you move 7 up, this thing right here becomes e to the x plus 4 plus 7. And then when you negate it, you get minus 7. So just be careful. Yeah. So sometimes like order matters. Everyone clear so far? That's honestly the only thing that's hard about. Whoa, that's not good. Oh, I just lost it. Okay. Yeah. Okay, so let's go over trig functions, right? So really for trig functions, the only thing I guess a lot of people forgot their trig is 45, 45 triangles, right? So I guess you would be more used to something like this. Yeah, anyway, 45, I guess people like the triangle on the right. So the ratio is 1, 1, root 2, right? If you remember. And then for 30, 60, I guess people like the 30 here. It doesn't matter. So 30, 60, you look opposite, right? So the opposite, this is 1. This is, I think, root 3. And the hypotenuse is 2, right? That's like the ratio of like the sides, if you all recall. So always remember the side opposite of like 60 is root 3. The side opposite of 30 is 1. Right? So I trust, you all know how to convert degrees to radians. So basically sine is opposite hypotenuse. And then cosine is adjacent hypotenuse. And let's just start there, right? So basically, if I say sine of pi over 4, that's sine of 45 degrees, right? I trust you know that how to convert this. So what you do is, you look at the circle, right? You start here, you go 45 degrees, so it's like halfway, right? And then you make a, and then what's the ratio here? The ratio is 1 root 2, right? Right, the sides opposite of 45 is 1s, and the side opposite of the 90 degree is root 2. So what's sine? You look at it, right? This is the angle, right? 45. Opposite is 1, and then hypotenuse is root 2. Yeah. So another, just another example, like cosine of, I don't know, 2 pi over 3. So this is cosine of, if you recall, it's 120 degrees, right? So let's shift 120. So if I shift all the way to the whole line, like if I go all the way here, I'm moving 180 degrees, right? Half a circle. So you see there's like 60 degrees left, right? Because I moved 120. So then again, 90, 30, and then what is the ratio, right? 30 is 1, this is root 3, and 2, so this is negative 1. So what's cosine? Just cosine is adjacent hypotenuse, right? So what's adjacent to 60 is negative 1, and the hypotenuse is 2, so it's negative a half. So, yeah, I mean, sine, cosine, tangent, like all the rest it's just, you just look at the triangle and then you compute, right? Everyone clear so far? I hope this is all review. It's trig, but let's move on. So let me just quickly, the graph of sine is like this. So you see it's a wave, right? So it's 2 pi periodic, right? So if you like at 0, this is pi over 2. This point here is pi. This point's here 3 pi over 2, and then this is 2 pi, right? So every 2 pi, it becomes the same, right? Because if I start here, this thing right here, and then this thing right here, bad at drawing, right? I mean, it's like symmetric. So every two, so you have this result that like sine of x plus 2 pi equals sine of x, right? And then same for cosine. Cosine is just shifted. It's like a shifted sine. It's like you shift this point to the beginning. So you start at 1, and then you make the same wave, right? This y value is 1. And then same thing, right? So right here is 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? So this is one wave, if you like. And you sort of see the question we had before was, the question we had before was what? It was 2 pi over 3, right? So you see, and we got negative a half, and you see it sort of matches the picture, right? Because where is 2 pi over 3? 2 pi over 3 is between pi and 3 pi over 2. It's somewhere here. Yeah, so you see it's, negative a half, apparently. Everyone clear so far? So this is review of trig. Any questions? Can I move on? Okay. So now we're going to talk about inverse functions, more in depth, right? So recall, if you like, you think of it as if you take x to y back to x, but really another way to define it is it's the function where if you compose, you get x. So f inverse of f of x is x. So one example we had was exponential functions, right? These are equations of the form f of x is b to the x, right? B is some number. So from here, you can ask, what's the inverse, right? Because how do you graph b to the x? This thing is like this, right? It's certainly one-to-one, right? It passes the horizontal line test. So it should have, it should have an inverse, at least from on whatever the range is. So it turns out we call the inverse, it's just the name, log b of x. So immediately you get two results, right? Because by definition, I have f of f inverse of x is x, right? So what is f of f inverse? So this should be review, right? How do you compose two functions, right? This is f of log b of x. So you plug in log b of x here to x, right? So b to the log b of x is x. So I think this is one of the rules in your book. And then vice versa, f of x. This is f inverse of b to the x. So here, right, I'm plugging in b to the x for x, right? This is also x. So that's how your book got these two rules. It's just using this, right? So before I go over how to calculate log, right, let's sort of go over the rules, right? So log base b, what happens if you multiply two things, right? It turns out you could add. So you could separate it by adding. And then log base b of x over y is subtracting. And then we have a nice thing where we can move powers down. So this is going to be important later on. So make sure you know this when we learn like derivatives and stuff. Log b of like, I don't know. So let me just say, log b of a to the c is c log b of a, right? Yeah, so you could bring powers outside. So instead of taking log b of a to some power, it's just that power times log b of a. So these are like, I'll just write properties of logarithm. So we're gonna practice, in some cases, finding out what log is. Yeah, so let's do an example, like log 2 of 32, right, is what? So let's think backwards, right? What did the exponential do? If exponential, takes x to y, log should take y to x, right? So you should ask, we work backwards, right? So the question you should ask here is 2 to the what power gives 32? That is your answer, right? In this case, it's 5, right? And you see that it matches with this notation, right? Because you're asking b to the what power is b to the x. Well, it's x, right? so you see it sort of matches at least, it confirms this. So that's how you calculate and then similarly, I don't really have example, but like if you have something like log 2 of, let me try to make something up. 12 plus log, let me think. What do I want? And then come with 8 plus log 2 of. So you could do this many ways, right? So you could solve each of them individually, or you could, use the rule that you could combine it, right? If you add, you can do. So let me just say method 1. We're going to use this law. So we're going to use this, right? Log of, we're going backwards. If we sum, it's the same as multiplying. So this is log 2 of 8 times 16. What is 8 times 16? 144? Or okay. This might be a bad example, actually. Let me see. 2 to the what power is 144? No. It's not 144. It's 128, right? I don't know why I thought 124. So this is 2 to the what power is 128? It's 2 to the 9, I believe, right? And another way you could do is, 2 to the what power is 8. 2 cubed is 8, right? So this is, or maybe it's 7, sorry. Yeah. Plus, and then 2 to the what power is 16, it's 4, right? So, yeah. So whenever you're evaluating logarithms, you ask yourself, like, your base to the what power gives whatever your thing is. So in general, log AB, whatever this equals, it's A to the what power is B. That's the, and you see in some cases it's hard, right? Like for example, like for this you need a calculator, because this is asking 2 to the what power is 5. So, I mean, 2 squared is 4, 2 cubed is 8, right? So it's some number between 2 and 3. But, I mean, to find this is, kind of difficult sometimes. Everyone good so far? So, special case, for e to the x, right? The inverse, like we have, I don't know why, but we abbreviate it as ln of x. Yeah. So ln is just short for log base e, right? So this is like special notation. And if you like, the graph of the exponential is like this, right? And then the graph natural log goes like this. So this is like e to the x. This is ln of x, right? So both of them still go off to infinity when you go to infinity in the x, positive x direction. Because, I mean, this gets big, right? When b gets more and more huge, I mean, you have to raise a to a higher and higher power, right, to get b. So that's for now, that's all you need to know, right? Just properties of log. So I want to spend a lot of time on inverse trig functions, because I feel this will really confuse people. So let's go to that. So a priori, right, if f of x is sine x, this is just notation, right? We denote the inverse as sine inverse of x. But if you notice, your book writes something like this, right? So, oh, sorry. Why? Actually, sorry. Let me just say, x is in between. So why does the book do this? So if you notice the graph of sine, right? Does sine pass the horizontal line test? Yes or no? Yeah, it's super bad, right? I mean, at least for like x squared, right? It hits 2 points. Like this thing, you could draw a horizontal line that hits like infinitely many points, right? It's like super bad. So it's not 1-to-1. So sine is not invertible, right? A priori. So, but sine is like a wave. I mean, so we could just consider it on here. So sorry, let me erase that. That's not right. I'll just write in red. We consider it here. Let me see, pi over 2, sorry. So we actually consider it. Let me redraw. So negative pi over 2 starts here, right? And then we go all the way to here. Yeah, to pi over 2. So if you, let me make it more clear. I'll draw it bigger. So we're only considering this interval. Because you see any further, it fails the horizontal line test, right? I mean, in a sense. So we really only care about like up to here, right? Because if I went up, it will fail, right? If I go a little down, it will fail the horizontal line test. So you see, like the book makes this choice, right? So that's just a choice the book makes. You could define the inverse as like here, right? But by convention, we go with negative pi over 2 to pi over 2. And then similarly, we have cosine. Let me go back to black. F of x is cosine inverse. Cosine, cosine. So cosine also fails the horizontal line test, right? So you need a choice of like which part of cosine you want. So the book makes this choice. Yeah. And then similarly, it follows that tangent is tan inverse lies in this interval. So don't ask me why they chose this, right? It's just it's just the choice they made. They could have chose a different part of the wave, but that's what they chose, right? So on here, right? So on here, right here, sine is 1-to-1 and it's invertible. It passes the horizontal line test. Okay, with that being said, let's practice calculating inverse functions. So really quickly, if sine, right, let me just write it in words, takes an angle to a number, right? So what should inverse of sine do? Can anyone tell me? So think of what inverse functions do. If a function takes x to y, the inverse takes y to x, right? So inverse of sine should take number to an angle, right? So with this, I mean, it's the same as natural log, right? I mean, you're just doing the same exact thing. So if I put like sine inverse of 1, right? You're asking, right? It takes in a number. It should spit out an angle, right? This question mark, it should be an angle, right? So you should see the question you should ask is sine of what angle is 1? This you can answer. So what's the answer? Yeah, pi over 2, right? But now you sort of see why we needed that interval, right? Because a priori, did I erase this? From here, right? From this rule, it's 2 pi periodic. So you see that not only like 2 pi plus pi over 2 is also 1, right? 4 pi plus pi over 2 is also 1, right? I mean, every 2 pi, it's like a wave, right? It should hit 1 infinitely many times. So you see why it's important for us to restrict, right? So from here, right, we restricted the inverse from negative pi over 2 to pi over 2, right? So our answer in this case is this one, right? If you chose a different, like I said, if you chose a different part of the wave, then your solution would be like 2 pi plus pi over 2, or like 4 pi plus pi over 2. So we restricted to like negative pi over 2 to pi over 2 so we can have a unique answer, right? So the inverse takes this to pi over 2. So let's practice a bit more, because I know it's kind of weird thinking backwards. So let's do cosine of a half. Yeah. So again, your question is cosine of what angle is 1/2, right? So for people who might struggle with this, the first thing I suggest you do, unless the thing is 1, -1, 0, or 0, right? If it's not those three numbers, you look at this, right? Then you ask yourself, because I mean, sine and cosine is just opposite hypotenuse, whatever hypotenuse, right? So you ask yourself, out of these triangles, how can I get a half? Well, first off, they're yeah, but like just going a bit slower. So first off, this has no 2 in it, so it's obviously this one, right? So you want the 1 and 2, right? Because 1 and 2, right? 1 divided by 2 is a half. So but cosine is adjacent, right? So you want the angle where it's you want the angle where the adjacent is 1. Yeah, I'm skipping some steps. So you want something where where this is your angle, the adjacent is 1 and hypotenuse is 2, right? And if you remember, always remember, like, what does the 1 correspond to? It's the opposite of 30, right? If you go, so the opposite of 30 should be 1, and then the opposite of 60 is √3, right? So you see here that when you take cosine of 60, it's a half. And another way to write, 60 is pi over 3. And again, there's 2 pi plus pi over 3, and so on and so forth. But we restrict it to here, right? Pi over 3 is in the interval 0 to pi. So we're good. Is everyone clear so far? Everyone comfortable so far? We're gonna get the harder stuff, but okay. Unit circle. Yeah, this is all in the unit circle. That's it's normalized, right? Because so let me go back. Where did I? This is on the unit circle because everything is like, how do I say this? because like the unit circle is this, right? So here, right, I'm doing 1 squared. Let me think. Oh, I take it back. Yeah, it's on the unit circle, cause. Oh, okay. The ratio are the same, is the same, right? Because let me, you know, I'm taking my angle. So if you if you want this to be 1, right, the ratio will still be the same. Because if this is 45, right, you have x and x, right? So you have x squared plus x squared is 1. So you get 2x squared is 1. And then you get x is 1 over root 2, right? So if you want to be on the unit circle, it's going to be 1 over root 2, 1 over root 2, right? But you see the ratio is still the same, right? If I go opposite hypotenuse right here, it's still 1 over root 2. Same as here. If I went opposite hypotenuse, it's still 1 over root 2. So like yes, you could normalize it to be in the unit circle. So this is not. But sine and cosine, I mean, even though the lengths might be differ by a scalar, by a number, when you take the ratios, it should remain the same. So it's fine. Are you clear on that? So like oh, okay. So I think this is convention. You know, people like this this type of. Hold on, let me turn off the. Yeah, so people like the 1 root 2 because like this, you know, people don't like dividing by square roots. So like it's very people don't like that. So yeah, we just go with 1 root 2 and 1 root 3 and 2. Okay, so let's get to something harder. So you know, this might scare you, right? But really it's the exact same thing. So like right? So now the question becomes this, right? But this should make sense, right? If you just calm down and think of what's happening, it's not that hard. So again, cosine inverse of 1, what is that? Like a number, an angle, what is it? So forget like what the value is. Like what is it? Is it a number? Is it an angle? Just this part. Anyone? Again, it's an angle, right? Because cosine takes number to angle. I mean, takes angle to number. So the cosine inverse should take number to angle. So really, this is all. So once I find what this angle is, the question is easy. It's just asking tan of the angle, right? So it's tan of the angle, right? So so let's figure out what this angle is, right? It's just a 2-step process. So what's cosine inverse of 1? Cosine of what angle is 1? So this should be easy because if you graph cosine, it starts at 1, right? So since it starts at 1, this is just tan of 0. What's tan of 0? So, oh, I guess I didn't go over tan, but tan, there's 2 ways to think of it. It's sine over cosine. And if you like the triangle, it's, I mean, you could infer from here, right? This is opposite over hypotenuse. This is adjacent over hypotenuse, right? So if you divide, you get opposite over adjacent, right? in this case, like it's just sine of 0 over cosine of 0. Cosine of 0 is 1. Sine of 0, you know the graph of sine at 0 is 0, right? Right here. So this is just 0. Yeah. So let's do something maybe a bit tan of cosine inverse of root 3 over 2, right? So again, this is just 2 steps, right? And it looks scary, but really this is an angle, right? Once you find that angle, you just take tan of that angle, right? So let's root 3 over 2, right? Well, which type of triangle has, you know, a root 3 in it? Obviously, it's the 30, 60, 90, right? Not the 45, 45. So we want root 3 over 2. So I want the adjacent, right? Cosine's adjacent, right? So I want root 3 over 2, and this is my angle. So how am I going to get the root 3 on bottom? Well, root 3 is the opposite of 60. So 60 should be here, 30 should be here, right? And then from here on, adjacent over hypotenuse is just, so yeah, root 3 over 2. So it's pi over 6, right? Tan of pi over, and then it's asking what's tan of pi over 6? Well, I have the triangle. Tan is opposite, tan x is opposite over adjacent. So it's opposite is 1 and adjacent is root 3, right? I guess some of you prefer this. Okay, everyone good on this. And then the opposite is true, right? So if I had cosine inverse of like tan of pi over 3, for example, we can also solve this, right? And this makes sense, right? Tan of pi over 3 is a number. Let's forget, you know, what it is. And then I'm taking cosine inverse of a number, right? So my answer should be an angle. Does everyone agree? Because the inverse function takes a number to an angle. Everyone agree? Yes or no? So this is a number, and then cosine inverse of a number is just some angle, right? So again, you work inside and outside, right? What's tan of pi over 3? Pi over 3 is 60 degrees, right? So this time you're given the degree, and then you figure out the triangle, right? If I'm 60, the opposite of 60 is root 3. Opposite of 30 is 1, right? So I'm opposite over adjacent, so it's root 3 over 1. Did I do this correctly? Yeah. Oh, this might be a problem, actually. Let me think. This is actually non-solvable. Now that I think about it, I made a bad example. So I mean, in this case, I guess I didn't pair nice numbers, but this thing is asking cosine of this is actually this is no solution actually. Let me think. Yeah, so I guess the problem here is tangent takes an element here. So in this case, this thing is no solution. Well, I mean, I guess unless he puts no solution as part of the answer, then you put, because in this case, root 3 is like 1 point something. I mean, right? And cosine only goes up to 1. So not going to happen, right? But the idea is if you get a number, it's again, you're asking cosine of what angle is root 3. I think the questions in your book should have stuff with solutions, right? You should end up with like something like So let me do one with a solution. So let's do cosine inverse of tangent of pi over 4. Yes, this will work. So let's do this. So tan of pi over 4, that's a 45 degree triangle, right? So it's 1, 1, root 2. So opposite over adjacent is 1. So it's cosine inverse of 1. And then now you're asking cosine of what angle is 1? That's 0. Yeah. Sorry for that mess up. Gave a bad example. Is everyone clear? So there's two things they can ask you. They either do inverse first, and then, you know, regular trig function, or they're gonna ask you a regular trig function first and then inverse, right? So just know in this case you get a number, and in this case you get an angle, right? This is the angle 0. If you like 0 degree. Everyone good on this? Yes? No? Okay, cool. Yeah, it looks scary at first, right? When you like, what on earth, like cosine of tan? But just do it like, inside to out, and then you should be fine. Right? Sometimes the examples will go, here, right? So you just, but it's the same exact process. Okay, that's all I have for today. Does anyone have like other questions you have? Like maybe I have like 3 more minutes if you have like a homework question. But you have to type it out because I'm not on WebAssign. So again, your quiz starts this Friday, right? I think I made it last until Monday night.